Introduction to probability. First, let's explore some vocabulary words. An experiment. An experiment is any process that generates well-defined outcomes. If we flip a coin, there are two possible outcomes that could occur. The coin could land on heads, or the coin could land on tails. Thus, we could refer to flipping a coin as an experiment, since we can clearly define the only two possible outcomes. Experimental outcomes are the possible outcomes of an experiment. For our example, heads is one possible experimental outcome and tails is the other. Probability. Probability is the numerical likelihood that an experimental outcome will occur. Some basic rules of probability. The first two bolded items on this slide are the two basic rules of probability. First, probability values are always assigned on a scale from 0 to 1. And second, if you sum the probabilities of all experimental outcomes of an experiment, they must sum to 1. A probability value that is close to 0 indicates that this outcome is very unlikely to occur. If the probability value equals 0, this indicates that this outcome will never occur. A probability value that's close to 1 indicates that it is almost certain that this outcome will occur. If the probability value equals 1, it is definite that that outcome will occur. A probability value of 0.5 indicates that it is equally likely as it is unlikely that that outcome will occur. On this slide, we show three popular methods of assigning probabilities: the classical method, the relative frequency method, and the subjective method. The classical method. This method is appropriate when you can assume that it is equally likely that each experimental outcome will occur. Examples of when this method would be applicable would include flipping a coin. When we flip a coin, we assume that it is equally likely that you could get heads as it is that you could get tails. This is also applicable whenever you roll a die. 1, 2, 3, 4, 5, and 6 are different faces of the die, and it is equally likely that either of those faces could appear upward. Also, when you are playing the lottery, we assume that it is equally likely that either of the numbers could occur. Example 1. When you roll a die, as we said, the sample space, which is denoted as a capital S with the open brackets, the sample space when you roll a die includes 1, 2, 3, 4, 5, and 6. It is equally likely that each sample point has a chance of occurring. For the classical method, if an experiment has n possible outcomes, then there is a 1 over n probability that each outcome will occur. So in this case, since there are 6 possible outcomes, each sample point, also known as an experimental outcome, has a 1/6 chance of occurring. With the relative frequency method, Probability values are assigned to experimental outcomes based upon historical data. Here in example 2, we review the historical data for a telemarketing company. With this company, they contacted 40 potential customers and recorded the frequencies of the number of magazines purchased by each customer. Their historical data shows that 16 customers purchased 0 magazines, 8 customers purchased 1 magazine, 10 customers purchased 2 magazines, 4 customers purchased 3 magazines, and 2 customers purchased 4 magazines. Using the relative frequency method, we can compute the relative frequency for each of these classes. The relative frequency for each class or number of magazines purchased will become equivalent to the probability of that experimental outcome occurring. Accordingly, we say that there is a 0.4 probability that if you call a customer, they will purchase 0 magazines. There's a 0.2 probability that a customer will purchase 1 magazine, a 0.25 probability that a customer will purchase 2 magazines, a 0.1 probability that a customer will purchase 3 magazines, and a 0.5 probability that a customer will purchase 4 magazines. As we discussed in a previous section, if you sum the relative frequencies for all of your classes, you will obtain the value 1. This makes this technique appropriate for assigning probabilities. Notice each of the values that we have are indeed, each probability value are between 0 and 1, and when you sum the probabilities of all of your experimental outcomes occurring, they sum to 1. The subjective method, as the title suggests, is completely subjective. There are many times in which you can examine different experimental outcomes and realize that it is not equally likely that each experimental outcome could occur, and historical data is not particularly useful. With this method, we use expert intuition as well as some historical data in order to determine what subjective estimates would be most appropriate. Subjective method examples. First, the Williams sisters. Historically, whenever the Williams sisters will meet up against one another in a championship game, we have seen that the individual playing record of the sister for that season has often not been useful in predicting which sister would prevail in the championship. Instead, other information such as injuries, which sister had been victorious the most in the most recent matchups between the two, and other soft information come into play. This is why when you have different commentators making subjective estimates on which sister is going to be victorious, we often get very varying opinions. Another example would be basketball games. One of my favorite matchups that I used to enjoy watching was Dennis Rodman whenever he played Karl the Mailman Malone. During these matchups, we saw that regardless of how the mailman season had been going up until that point, these two men had a very special chemistry or rivalry that definitely existed between them. Rodman was notoriously known for whispering in the mailman's ear or making different comments to him that he knew would send him completely off of his game. Because of the dynamics between these two men, as well as injury information and other information about different matchups that are expected to be seen in any particular basketball game, once again, we have different commentators giving different opinions about who they expect to be victorious in the upcoming matchup.